The robots are taking over. First they were doing backflips, and now even dogs are losing their jobs. But what I bet you've never seen is a robot playing rock, paper, scissors. In order to broker a peace deal between robots and humans, I'm going to give a robotic hand the ability to play rock, paper, scissors using the human body as the communication protocol. Before I can make a robotic hand play rock, paper, scissors, I need a robotic hand. Good news is, I built one. Here's how I did it. I made the design, 3D printed it, and then assembled it. The hand relies on a pulley system that replicates the tendons that you probably have in your hands. Electrically, I used a current sensing system to know when an object's being gripped, and then multiplied this by 5 for each finger. Are thumbs fingers? I don't know. Point is, it's the same system. I can control this hand-shaped husk using an electromyography sensor, which detects a potential difference on the surface of my skin. And when it detects it, it tells the hand to go brr. Bang! Achievement unlocked. Gripping objects is now possible. But to be able to play rock, paper, scissors, I need to be able to distinguish between different gestures, and Handy can definitely do that. And yes, I am calling it Handy now. I mean, it's so beautiful. It's got such a personality to it, and oh, what am I doing? To fix that, I need some electronics. So we're left with this. We got my electromyography sensor taped to my bipolar voltage source. I've then got my analog to digital converter chip, all connected to my Raspberry Pi. And no, that's not a food, it's a controller. So I have now hooked up myself to that live circuit. Now when I clench my fist, what you can see is this big value spike. That's a voltage spike, and it's reading the potential difference across my muscles. When I make a different gesture, for example paper, you can see that it spikes, but the behavior's a little bit different. And what about scissors? All I then need to do is say, okay, well, rock looks like this and paper looks like this, and we're done, right? Easy. Not easy. Taking just those peak values isn't going to give us enough information about exactly what gesture is being performed. Basically, rock is going to be too easily confused with paper, and paper is going to be too easily confused with scissors, etc, etc. So instead, we've got to take a look at their time variant values to get some additional information. So this is the waveform that's seen when I'm at rest, and when I close my fist, you can see that there's a peak in the value. We've seen that before, but what's more important is the shape of this waveform over time. If I was to do paper, you can see there's a spike. This is what we're seeing, but the shape of that waveform is noticeably different. And if I do scissors, it's the same thing. If I'm then to do rock again, what you should hopefully see is, yes, that peak value, but actually that waveform over time is very similar to the first rock. I need to create a system that's able to look at that long waveform and go, that's rock, that's paper, and that's scissors. One of the best ways, or the one I'm going to use to do this, is a classification system. Let's say I'm a classification system. Here is a biscuit, an apple, and a banana. A sweaty programmer has trained me on a bunch of data and forced me, without my consent, to eat a biscuit, a banana, and an apple. Now, when I get fed the data, again, without my consent, I can easily say that that was a biscuit. And I could do the same for apples and bananas. The more biscuits the programmer feeds me, i.e. the more data I have to make my decisions on, the more accurate I'm gonna be at getting my decision making correct. Equally, the more rock gestures, paper gestures, and scissor gestures I give my classification system, the more likely it's going to be accurate. So, data collection time. With this $30 muscle sensor I bought online, now I can go about making my data set. I could probably build a better version of this. That's a pretty bold statement. Let me explain why I want to. Imagine you have a building. You need two things for this building, a foundation and a body. The body can look as nice as it wants, be made out of solid gold and have 1,000 floors, and even one of those things you get at overpriced sushi restaurants. But none of it matters if the foundation is made of wood, because the building's just gonna topple over. Equally, if I build my fancy classification system on top of a crap muscle sensor, which gives me an inconsistent value, my quality of my classification system, it's just not going to matter. It's never going to get anything right because the sensor it's built on is wrong. So that's easy enough, right? No. Differential amplification, low pass filter, high pass filter, adjustable amplification, voltage follower, voltage offset, epidermis, transcephual potential, dynamometry, milliamps, microamps, too many amps, too little volts, too many volts, positive volts, negative volts, SEMG, MUAPs, precision full wave rectifier, TL072, INA 106, fastest solution, isometric and tonic contraction, neuromuscular junction, simulation, oscilloscope, oscilloscope, resistors, capacitor, break, rebuild, break, rebuild, simulate, change everything, build again, break. Seriously, why isn't this working? Rebuild, simulate, please work. Yes, looks right. Buy, solder, break, solder, resolder, work, sorta, buy, work, resolder, work. You guys have no idea how ass this thing was to make, but I did it. This thing took me so long to build, I have literally partially grown facial hair. It took like 3 weeks. I haven't seen my family. I haven't cleaned my room. It's a total mess. But it works. It works. Look at this. So in the top left, you've got the store-bought EMG, and in the bottom left, you've got my EMG. The big difference between these two is you can see how the signal varies. In this, I'm just closing my fist, but you can see there's a spike value on the store-bought one, and then the signal just kind of dies off. The reason it's doing that is because this EMG isn't great at distinguishing between the DC components of my amplitude wave and the DC components that are introduced that you want to get rid of. My circuit's a little bit better at doing that. On top of that, my circuit also only needs one battery, which was really ass to design for, and I have no idea why I went through so much hassle of doing it, but I did it, and now I have one less battery that I need in my circuit. Yes! The classification system is artificial intelligence, and AI requires an absolute crap ton of data to make its decisions. My system had no data, because I was the only person in the world who had this muscle sensor, because I was the one who built it. That meant I had to collect data about what the voltage waveform looked like for each gesture myself. This took a long time, so I set up a cheeky little movie and got to gripping. Good news is I managed to bulk up my left arm a bit in the process, as after all it was falling a bit behind my right arm. So here's that classification code in action. I'm going to prompt the computer to ask myself for a gesture, I'm going to make a fist, and then it should hopefully tell me I've made a fist. I'm going to do the exact same thing for scissors. Prompt it, it's going to make the scissors, and then hopefully it tells me it's scissors. There you go. Now I'm going to keep on doing this until it gets it wrong, and I'm going to fast forward. Right, so that was about 10 tries or so. I don't know the exact count. About 10 tries or so, and it got it wrong. The linear regression had about an 80 to 90% approximation rate of being correct, so that actually lines up perfectly. Okay, so full disclosure, this next bit's, it's a little bit kooky. My decision making is happening with my Raspberry Pi, and my hand runs on an Arduino, so I need a communication protocol between the two. This is essentially how I'm going to do it. When I clasp my hand, that LED should light up if everything works. So I'm going to prompt, make my gesture. It's going to go, oh, I wonder what gesture he's making. And then boom, I was making a fist. So that lit up the red LED. So all is working. Now it's time to put it into the hand. Please work, please work. Right, ignore this pinky motor. It's totally messed up. I don't have another motor and I can't be bothered fixing it. Right. Rock, paper, scissors, rock.
We shall never surrender.
Work.
Success!
Okay. Rock, paper, scissors. Shoot. Let's go for paper. Let's go for scissors. Okay. Oh, didn't really roll back that. Oh, it's because of the battery.
Success!
Hell yeah. Okay. This, for the record, this motor, this was the one that's busted, and I don't have another motor, and it won't arrive for another 20 days, so that's what you're getting. Okay, right, let's go for paper now. And paper's just a flat gesture. Okay, paper. So hopefully nothing happens. paper, nothing happens. Alright guys, that's the video. Thank you very much for watching. Sub or the robot army will come and get you. Become a bot today. Goodbye.